what number is the logarithm of 10 raised to 4.40 equivalent to? A, 1. B, 4.40. C, 10. 5 seconds, go. Time's up. If you answered
Panginoon po namin Diyos, maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataon maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live Facebook live streaming in General Mathematics. I am pleased to be with you once more. Come and join me as we venture on today's learning experience. Are you ready? Let's start. We are now on quarter 1, week 8, which is about more on logarithmic functions. At the end of this session, you are expected to meet the following most essential learning competencies. First, represent a logarithmic function through its table of values, graph, and equation. Second, find the domain and range of a logarithmic function. Third, determine the intercepts, zero, and asymptotes of logarithmic functions. And fourth, solve problems involving logarithmic functions, equations, and inequalities. Let us start today's session with our first activity entitled Remember Me. I will be flashing some logarithmic expressions. Simply recall the properties of logarithm to be applied to come up with a correct answer. 5 seconds will be given for you to drop your answer in the comment box. Are you ready? Let us begin. Number 1. What is the value of logarithm of 9 with base 9? A, 0. B, 1. C, 9. 5 seconds, go. Time's up. The correct answer is B, 1. Second, to what number is the logarithm of 10 raised to 4.40 equivalent to? A, 1. B, 4.40. C, 10. 5 seconds, go. Time's up. If you answered B, 4.40, you got it right. Number 3. Determine the value of ln of e raised to 0.0251. A, 0.0251. B, 1. C, 10. 5 seconds, go. Time's up. If you answered A, 0.0251, you are correct. Number 4. Which expression is equivalent to logarithm of 5 over 2 with base 4? A, logarithm of 5 with base 4 plus logarithm of 2 with base 4. B, logarithm of 5 with base 4 divided by logarithm of 2 with base 4. C, logarithm of 5 with base 4 minus logarithm of 2 with base 4. You've got 5 seconds. Go. Time's up. If you answered C, logarithm of 5 with base 4 minus logarithm of 2 with base 4, you are correct. What is your score, grade 11? Good job. It seems that you remembered well the past lesson. Now, let us recall the logarithmic function. Let A and B be positive real numbers such that P is not equal to 1 and C be any real number. The logarithm of A with base B is denoted by logarithm of A with base B and is defined as C is equal to logarithm of A with base B if and only if A is equal to B raised to C. Logarithmic function may be presented in 3 different ways, namely table of values, graph, and equation. Let us have an example to illustrate this. Given the logarithmic function f of x is equal to logarithm of x with base 2, let us construct table of values for this, where negative 2, negative 1, 0, 1, and 2 are values for f of x. From the table, we need to solve for the value of x to accomplish it. The logarithmic function f of x is equal to logarithm of x with base 2 is similar to y is equal to logarithm of x with base 2. Rewriting this to exponential function, we have x is equal to 2 raised to y. We are now ready to solve for the values of x. That is, we substitute values of y to our equation one at a time. That is, we substitute negative 2 to the variable y, and we have 2 raised to negative 2. By loss of exponents, this is equivalent to 2 to 1 over 2 raised to 2. 2 raised to 2 is 4. So this is equal to 1 over 4. Next, let us substitute negative 1 to the variable y, and we will have 2 raised to negative 1. By loss of exponents, this is similar to 1 over 2 raised to 1. 2 raised to 1 is 2. So x is equal to 1/2 is the final answer. Next, substitute 0 to the variable y. We have 2 raised to 0. What is 2 raised to 0? Correct, 1. So x is equal to 1 is the final answer. Now, let us substitute 1 to the variable y. We have 2 raised to 1. 2 raised to 1 is 2. So we have x is equal to 2 as the final answer. Last, let us substitute 2 to the variable y. We have 2 raised to 2, which is equivalent to x is equal to 4. That's it. We're done with the table of values. We are now ready to plot these points in the Cartesian plane. Given the table of values, let us plot the points 1 over 4 or 0.25 comma negative 2, 1 over 2 or 0.5 comma negative 1, 1 comma 0, 2 comma 1, and 4 comma 2. Connecting the points will show us the graph of logarithmic function f of x is equal to logarithm of x with base 2. Did you get it, grade 11? I hope so. Here are additional examples of logarithmic functions represented as equation, table of values, and graph. First, we have f of x is equal to negative logarithm of x with base 2. Next, we have f of x is equal to negative logarithm of the quantity x plus 2 with base 2. Then we have f of x is equal to logarithm of the quantity x plus 2 with base 2. I hope representing logarithmic functions is now easy for you. Next, let us discuss domain and range of logarithmic function. How do we get the domain of logarithmic function? Let us remember that the domain of the logarithmic function y is equal to a times the logarithm of p of x with base b is x such that p of x is greater than 0. Let us illustrate this with our examples. That is, we find the domain and range of number 1, f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3. And number 2, f of x is equal to 4 times the logarithm of x with base 2 minus 8. For number 1, where f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3, p of x is equal to x plus 9. To get its domain, we set p of x is greater than 0. That is, x plus 9 is greater than 0 and solve for x. Subtract 9 from both sides. We have x is greater than negative 9. So, domain is x such that x is greater than negative 9. Can you follow grade 11? I hope so. Let us proceed to the second example. F of x is equal to 4 times the logarithm of x with base 2 minus 8, where p of x is equal to x. To get its domain, we set p of x is greater than 0. That is, x is greater than 0 and solve for x. From here, it is clear that domain is x such that x is greater than 0. Did you get it, grade 11? Can you now find domain of logarithmic function with this? Great. What about its range? Remember that the range of logarithm of p of x with base b is the set of all real numbers. So, the range of any logarithmic function presented is the set of all real numbers as well. That is, for number 1, f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3. The range is the set of all real numbers. Number 2, f of x is equal to 4 times the logarithm of x with base 2 minus 8. The range is the set of all real numbers. Can you follow grade 11? Very good. Let us now have a quick check of your understanding about ways of representing logarithmic function and its domain and range with our second activity entitled Fact or Bluff. You will be given 5 seconds to hit the like reaction button if the statement is a fact, and hit the stop reaction button if the statement is a bluff. Ready? Number 1. The graph on the right represents logarithmic function. Is it a fact or a bluff? Time's up. If you answered fact, then you are correct. This is a graph of logarithmic function f of x is equal to logarithm of x with base 4. Number 2. The graph on the right represents a logarithmic function. Is it a fact or a bluff? Time's up. If you answered bluff, then you are correct. You may recall that this is the graph of exponential function f of x is equal to 2 raised to x. Moving on to the third statement, the table of values below represents a logarithmic function. Is it a fact or a bluff? Time's up. If you answered fact, then you are correct. The easiest way to verify this is to examine the values of x in the table. The values of x in the table appear to be a geometric sequence with common ratio equal to 3. So this is a table of values for a logarithmic function. Another way to verify is to plot the points in Cartesian plane and decide with its graph. That is, we plot in Cartesian plane 1 over 9, comma negative 2, 1 over 3, comma negative 1, 1, comma 0, 3, comma 1, 9, comma 2. Connect this point. What graph is illustrated now? Correct. Logarithmic function. Moving on to our fourth statement. The domain of f of x is equal to logarithm of the quantity x minus 2 with base 4 is x such that x is greater than 2. Is it a fact or a bluff? Time's up. If you answered fact, then you are correct. And for our last statement, the range of f of x is equal to logarithm of the quantity x minus 2 with base 4 is y such that y is greater than 0. Is it a fact or a bluff? Time's up. If you answered bluff, then you are correct, since the range of any logarithmic function is the set of all real numbers. What is your score? Good job, grade 11. I hope that representing logarithmic function through table of values, graph, and equation, as well as getting domain and range is now easy for you. Now, let us proceed to finding the intercepts, 0, and asymptote of logarithmic function by defining them first, then illustrating them using the logarithmic functions presented earlier. Intercepts are the points where the graph of a function crosses the axis. 0, the value of x when y is 0. Asymptote, the line at which the graph of a function gets closer and closer to, but never touches it. Let us find the intercepts, 0, and asymptote of the following logarithmic functions. Number 1, f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3. And number 2, f of x is equal to 4 times the logarithm of x with base 2 minus 8. For number 1, f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3. Solving for x-intercept, we set y to 0 and solve for x. That is, 0 is equal to 2 times the logarithm of the quantity x plus 9 with base 3. Dividing both sides by 2, we have 0 is equal to logarithm of the quantity x plus 9 with base 3. Rewrite this to exponential form. We have 3 raised to 0 is equal to x plus 9. 3 raised to 0 is 1. So, 1 is equal to x plus 9. Subtract both sides by 9. We have negative 8 is equal to x. Thus, the graph will pass through the point negative 8, 0. Solving for y-intercept, we set x to 0 and solve for y. That is, y is equal to 2 times the logarithm of the quantity 0 plus 9 with base 3, which is equivalent to 2 times the logarithm of 9 with base 3. But 9 here is the same as 3 raised to 2. So, we have 2 times the logarithm of 3 raised to 2 with base 3. Recall that one of the properties of logarithm is logarithm of b raised to c with base b is equal to c. That is, logarithm of 3 raised to 2 with base 3 is equal to 2. Applying the property of logarithm, we have 2 times 2. Last, get its product. So y is equal to 4. Thus, the graph will pass through the point 0, 4. The logarithmic function f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3 has domain x such that x is greater than negative 9. Since the permissible values of x are those that are greater than negative 9, then vertical asymptote is x is equal to negative 9. The graph will pass through y-axis at 0, 4 and x-axis at negative 8, 0. The value of the computed x-intercept is also its 0, which is negative 8. The graph of f of x is equal to 2 times the logarithm of the quantity x plus 9 with base 3, as well as its vertical asymptote, x-intercept, 0, and y-intercept is seen on my right. For number 2, f of x is equal to 4 times the logarithm of x with base 2 minus 8. Solving for x-intercept, we set y to 0 and solve for x. That is, 0 is equal to 4 times the logarithm of x with base 2 minus 8. Add 8 to both sides and we will get 8 is equal to 4 times the logarithm of x with base 2. Divide both sides by 4 and we will get 2 is equal to logarithm of x with base 2. Next, rewrite this to exponential form. We will get 2 raised to 2 is equal to x. 2 raised to 2 is 4. So we have 4 is equal to x. Hence, the graph will pass through the point 4, 0. To get the y-intercept, set x to 0 and solve for y. That is, y is equal to 4 times the logarithm of 0 with base 2 minus 8. Recall that logarithm is defined by c is equal to logarithm of a with base b, where a and b are positive real numbers, such that b is not equal to 1, and c is any real number. The 0 here is not a positive real number. So, logarithm of 0 with base 2 is not defined. Thus, y does not exist. This implies that the graph will not pass through the y-axis. The logarithmic function f of x is equal to 4 times the logarithm of x with base 2 minus 8 has domain x such that x is greater than 0. Since the permissible values of x are those that are greater than 0, then vertical asymptote is x is equal to 0. The graph will not pass through the y-axis since the y-intercept does not exist. But the graph will pass through the x-axis at 4, 0. The value computed in x-intercept is also its 0, which is 4. The graph of f of x is equal to 4 times the logarithm of x with base 2 minus 8, as well as its vertical asymptote, x-intercept, 0, is seen on my right, where the graph has no y-intercept. Let us now see how logarithmic functions and equations can be used in solving real-world problems. Problem number 1. The magnitude R of an earthquake is given by R is equal to 2 over 3 times the logarithm of E over 10 raised to 4.40, where E in joules is the energy released by the earthquake. How much energy was released during the August 2021 Batangas earthquake, which registered 5.8 magnitude? To solve the problem, we write first the given. The magnitude, denoted by R, is equal to 5.8, and energy in joules, denoted by E, is unknown. For the solution, we use the formula R is equal to 2 over 3 times the logarithm of E over 10 raised to 4.40. Then, we substitute 5.8 to the variable R, and we will get 5.8 is equal to 2 over 3 times the logarithm of E over 10 raised to 4.40. Next, multiply both sides by 3 over 2. The product of 3 over 2 and 2 over 3 in the right side of the equation is equal to 1, while 3 over 2 and 5 5.8 in the left side of the equation gives 8.7 as product. So we have 8.7 is equal to logarithm of e over 10 raised to 4.40. Applying laws of logarithm, this is equivalent to 8.7 is equal to logarithm of e minus logarithm of 10 raised to 4.40. Applying properties of logarithm in the expression logarithm 10 raised to 4.40, a value of 4.40 will be obtained. And we will have 8.7 is equal to logarithm of minus 4.40. From here, we will add 4.40 to both sides of our equation. That is, 8.7 plus 4.40 is equal to logarithm of e minus 4.40 plus 4.40. Negative 4.40 and positive 4.40 in the right side of the equation has a sum of 0, while 8.7 plus 4.40 will give a sum of 13.10. So, we will have 13.10 is equal to logarithm of e. Last, we're writing this to exponential form. We will have 10 raised to 13.10 is equal to e. Now, we go back to the problem and answer it. Therefore, the August 2021 Batangas earthquake released 10 raised to 13.10 joules. Moving on to our second problem, which is about logarithmic function. The population of the Philippines can be modeled by the function P of x is equal to 20 million times e raised to 0.0251x, where x is the number of years since 1955. Assuming that this model is accurate, in what year will the population reach 150 million? To solve the problem, we write first the given. The population denoted by P is equal to 150 million. And the number of years denoted by X is what we are looking for. For the solution, we use the given function P of X is equal to 20 million times E raised to 0.0251x. Then substitute the given. And we will have 150 million is equal to 20 million times E raised to 0.0251x. Next, divide both sides by 20 million. The 20 million in the numerator and denominator in the right side of the equation is equal to 1, while 150 million divided by 20 million in the left side of the equation is equal to 7.5. So, we will have 7.5 is equal to e raised to 0.0251x. Next is to take the ln of both sides. That is, ln of 7.5 is equal to ln of e raised to 0.0251x. By applying the properties of logarithm, we will come up with ln of 7.5 is equal to 0.0251x. Then divide both sides by 0.0251. 0.0251 in numerator and denominator of the right side of the equation gives an answer of 1. So we have ln of 7.5 over 0.0251 is equal to x. ln of 7.5 divided by 0.0251 is approximately equal to 80. So we have x is approximately equal to 80. It means that we add 80 to 1955 and we will get 2035. Going back to our problem, let us answer it. Based on this model, the Philippines will reach the 150 million populations by 2035. Now, let us proceed to our third and last activity entitled Your Turn. I will be flashing questions and you will be given 1 minute to answer them. Be ready with your pen, paper, and calculator that you will be needing in answering. Are you ready? Let us begin. First question. Find the intercepts, 0, and asymptote of the logarithmic function. F of x is equal to logarithm of the quantity x minus 1 with base 5. It's your turn, grade 11. 1 minute, go. Time's up. Let us verify your answer. The given logarithmic function is f of x is equal to logarithm of the quantity x minus 1 with base 5. Again, solving for x-intercept, we set y to 0 and solve for x. That is, 0 is equal to logarithm of the quantity x minus 1 with base 5. We write this to exponential form. We have x minus 1 is equal to 5 raised to 0. But 5 raised to 0 is 1. So we have x minus 1 is equal to 1. Adding 1 to both sides of our equation, we will give us an answer of x is equal to 2. Thus, the graph will pass through the x-axis at 2, 0. Again, solving for y-intercept, we set x to 0 and solve for y. That is, y is equal to logarithm of the quantity 0 minus 1 with base 5. This is equivalent to y is equal to logarithm of negative 1 with base 5. Recall that logarithm is defined by c is equal to logarithm of a with base b, where a and b are positive real numbers, such that b is not equal to 1 and c is any real number. Negative 1 here is not a positive real number. So, the value of y does not exist. This implies that the graph will not pass through the y-axis. The logarithmic function, f of x is equal to logarithm of the quantity x minus 1 with base 5, has domain x such that x is greater than 1. Since the permissible values of x are those that are greater than 1, then vertical asymptote is x is equal to 1. Also, y-intercept does not exist. X-intercept is at 2, 0. The computed x-intercept is also at 0, which is 2. Did you get the same answer? That is great. For our second and last problem, the pH level measures the acidity of a water-based solution by the concentration of hydrogen ions in the solution. It is obtained by pH is equal to negative logarithm times the concentration of hydrogen ion. A certain brand of vinegar was found to have 0.0026 moles of hydrogen ions. What is its pH level? It's your turn, grade 11. 1 minute, go. Time's up. Let us verify your answer. For the solution, given that pH is equal to negative logarithm of the concentration of the hydrogen ions, let us substitute the given moles of hydrogen ions, which is 0.0026, and we will have negative logarithm of 0.0026. But this is similar to logarithm of 0.0026 raised to negative 1, which may be expressed as logarithm of 1 over 0.0026. By loss of logarithm, this is the same as pH is equal to logarithm of 1 minus logarithm of 0.0026. Using a calculator, this is equivalent to approximately 2.59. Therefore, the pH level of a certain brand of vinegar is approximately 2.59. Let us now summarize our lesson for this day. What are the different ways to represent a logarithmic function? Logarithmic functions may be presented through table of values, graph, and equation. How do we solve for the domain and range of a logarithmic function? In logarithmic function, y is equal to a times the logarithm of p of x with base b. The domain is x such that p of x is greater than 0. However, the range of any logarithmic function is the set of real numbers. How do we solve for the intercepts of a logarithmic function? The y-intercept of a logarithmic function is solved by setting x to 0. The x-intercept, on the other hand, is solved by setting y to 0. What relationship exists between the x-intercept and 0 of logarithmic function? The value that is solved in x-intercept is also the 0 of the logarithmic function. How do we get the vertical asymptote of a logarithmic function? Given a logarithmic function with domain x such that x is greater than d, the vertical asymptote is the line x is equal to d. How do we solve problems involving logarithmic function and equation? First, identify the given quantities and the unknown quantity. Next, devise a plan on how to solve the problem. Last, carry out the plan and check your answer. Now, let us proceed to the frequently asked question about logarithmic functions. Why does the graph of a logarithmic function have no horizontal asymptote? The range of a logarithmic function is the set of all real numbers, so there is no restriction on its y values. Before we end today's session, let me just remind everyone to answer additional activities part of your module. Once again, this has been your general mathematics teacher for today. Saying goodbye for now. Stay safe and healthy. God bless everyone. Thank you.